So in this video we want to evaluate this particular integral here involving a radical expression in the integrand. And there's always, in a lot of cases, more than one approach to solving these problems. If you look at it as is there, it has the square root of 1 minus x squared in the denominator. So that looks like a trig substitution. Look at the different cases we have here. It fits the first one, the square root of a squared minus u squared, where the u is just x and the a is 1. So I could work this out as is. I could break it up into two integrals. One integral would be 1 over the square root of 1 minus x squared, and the other integral would be minus x over that same square root. And I could use a u substitution. But in that first integral, I'd still have to use the trig substitution. So I'm gonna leave it the way it is and see what we get here. So I'm gonna let sine theta equal to x. Or if you're looking at the triangle, it'll look this way. This will be theta there, the angle. We got a right triangle there, x. This would be 1. And this side will be the square root of 1 minus x squared. So taking the derivative here, we would have cosine theta equal to dx here. And this would be d theta here. So what we're going to do is transform this integral here into one involving the angle theta. So let's look at the radical first of all. Got 1 minus x squared, and x is sine. So for the radical, I'm going to have the square root of 1 minus, and then x is sine, so this will be sine squared theta. And you by now realizing when you're solving these types of problems using trig substitutions, you got to be familiar with your fundamental trig identities. We know that cosine squared theta plus sine squared theta equals to 1. So using that identity, we know that 1 minus sine squared theta can be replaced by cosine squared. Square root of cosine squared is cosine theta. So we got this. So let's come back over here then. And we're going to transform this into an integral involving theta. So this will be 1 minus, and x can be replaced by sine theta. I'll put parentheses on this one here. And then dx can be replaced by cosine theta d theta. And then of course the radical expression, as we saw over here on the left, can be replaced by cosine of theta. And then we can cancel here, cancel here, and we're left with the 1 minus sine theta over 1, so this will just be 1 minus sine theta d theta. And then we're ready to integrate here. Always remember the integration is, in this case, respect to theta. So the antiderivative of the integral 1 with respect to theta is theta. The integral of sine theta is minus cosine theta, so we have a minus there already, so that makes it a plus. Cosine theta. Now, since we did the integration, we need our constant of integration. And we're finished with the integration. The only thing we need to do, of course, when you do a substitution, you have to go back to the original variable. So let's go back over here. We know from this right here, sine theta is equal to x. So taking sine inverse of both sides, I get theta should equal to sine inverse of x. Or I could call that arcsine. So here it's sine inverse of x. And this is plus cosine theta. I go to the triangle over here, and I have the angle there theta. So cosine of theta is equal to the adjacent side, which is the radical over the hypotenuse, which is 1. So it's the square root of 1 minus x squared over 1, will just give me the square root of 1 minus x squared plus the constant of integration. And there's your answer. And again, there is at least one other approach you could have taken, but this one worked out fairly nice, not that lengthy. That's it for this video. Thanks for watching, and we'll see you next time.